And we've come to the point now in the course where we shift from right triangle trigonometry, which is the chief Sagatoa Pythagorean theorem type thing to solve triangles. And we're going to solve what are called oblique triangles. So in oblique triangles, an oblique triangle is simply a triangle that does not have a right angle. So if our triangles don't have right angles, in order to solve the triangle, and solving the triangle means finding all the angle lengths and the side measures, we have to use something called the law of sines and or the law of cosines. So here is the law of sines, and we're dealing with triangles. So in any triangle, they're using standard labeling. So standard labeling is the capital letters are angle measures, the lowercase letters are side lengths, and the law of sines simply state that side length A over the sine of angle A, that's equal to side length B over the sine of angle B, that's equal to side length C over the sine of C. And what we intend to do with the law of sines is we're going to take a proportion, right? A proportion is any fraction set equal to each other. In that proportion, there is only one unknown, and we can solve for that unknown by using that cross product property. Now, you may see this formula written in alternative ways. So the alternative way is you could put your angle measures in the top, and you can put your side lengths in the bottom. Okay, so there is no right or wrong way to set up your proportion. However, you have to be consistent. Right? If you're putting angle measures in the numerator, just make sure all of your angle measures are in the numerator. And if you're putting side lengths in the numerator, just make sure you just honor side lengths in the numerator. All right. So here is an example. All right, and this is problem number 1 from section module 4.1. And they give us the formula, right? So this is the law of sines formula, and we are to use the law of sine formulas to find the missing side length. So now, as far as a triangle is concerned, this is just the triangle fact. And this is true of any triangle, not necessarily a oblique triangle. The sum of the interior angles of any triangle is 180 degrees. All right, so this is just a fact. No matter what type of triangle you have, you should be able to add up all 3 angles, and they should sum up to be 180. Okay. So in these problems, we can't use a Pythagorean theorem, right? If you know 2 sides, in order to find the third side, right, we can't use the Pythagorean theorem because there is no right angle. The law of sines and the law of cosines will account for that. So it says find the length of side x, and they want us to round to the nearest tenths. So the first thing I'm just going to notice is that if I look at my triangle, I have 2 angle measures, and it's possible to find the third angle measure by using that sum formula, right, which says that all angles of any triangle add up to give me 180. So that's the first step. I'm going to find the unknown angle using the sum formula. Sometimes you're going to be able to find all three angle measures. Sometimes you're not. Sometimes, in this case, they give us two, but we're going to see an example in a second where they just give us one angle measure. So in order to find the measure of this unknown angle, the unknown angle, that's equal to 180 degrees minus the sum of the other 2 degrees. All right. So basically what I'm going to do is I'm going to add these two things together and subtract from 180, and that should give us this unknown angle. So if I put this into my calculator, 180 minus, I'm going to use a parenthesis, 75 plus 45, and we should get that unknown angle to be 60 degrees. So that's my first step. I'm going to find this unknown angle, and I'm just going to jot that in as 60 degrees. Now what I'm going to do here is I'm just going to use my law of cosines, my law of sines, and I'm going to find this unknown angle x. So here's the setup for the law of cosine, for the law of sines, You have your side length divided by the sine of the angle opposite that side length. So if I'm looking at my setup, I know this 60-degree angle, and I know my 7-degree side length, right? So I can use that as one fraction for my law of sines. So that's the second thing we're going to do is find x. So we're going to set up law of sines proportion. So I'm going to put my side lengths in the top and my angle measures in the bottom. So I have my side length 7, and I'm going to put that over the sine of 60 degrees. All right, so I have my side length divided by I have no idea where that's coming from. Oh, I hit this with my foot. I didn't even know that was in there. All right, so the first thing I did was I put my side length 7 over the sine of 60, and I'm going to set that equal to, I'm trying to find this unknown side, so I'm going to put that unknown side I'm trying to find in my numerator. And I'm going to divide that by the sine of the angle opposite that side length. So x is divided by the sine of 45 degrees. All right. Any questions about my proportion? I put side length 7 over the sine of 60 degrees, right? That's its angle, and that's its opposite angle from side 7. I set that equal to x divided by the sine of its opposite angle, which is 45 degrees. In order to solve this proportion, I'm going to cross multiply and divide. So I'm going to cross multiply. 7 times the sine of 45 degrees is 7 times the sine of 45 degrees. I'm going to set that equal to x times the sine of 60 degrees. And now I want to solve for x. So the opposite of multiplying x by the sine of 60 degrees is to divide by the sine of 60 degrees. So I'm going to divide both sides by the sine of 60 degrees. So I have 7 times the sine of 45 degrees divided by the sine of 60 degrees is equal to x. And I'm going to put this into the calculator. First off, I want to make sure I'm in the right mode. Since I have degree measures, I want to make sure that my calculator is set to degree mode. Right, so that's the first thing. Okay, so now I'm just going to enter in the expression 7 times the sine of 45 degrees divided by the sine of 60 degrees. And we have 5.7 and side length x. It doesn't really tell us what dimensions, but we have 5.7 units. All right, any questions about number 1? All right, we found the unknown angle, and then we just set up a law of sines proportion. The next one is, this is problem number 3. And here again, we're asked to, in this one, we're asked to find this missing angle measure. So you can not only find side lengths by using the law of sines, you can also find angle measures. So I'm going to set up another proportion. And I'm going to just be consistent with putting my side lengths in the numerator and my angle measures in the denominator. So just looking at my figure, I don't have enough information to find that third angle, but I do know that for my side length of 23, I can divide that by the sine of its opposite angle, which is 98 degrees. And I can set that equal to, right? So I don't know my missing side length, but I do know the side length opposite that missing angle. So I'm going to take 13, which is the side length. I'm going to put that in the numerator. And I want to divide by the sine of x, which is unknown. And now we want to solve it for x. So I'm going to cross multiply. 23 times sine x is 23 times the sine of x. I want to set that equal to 13 times the sine of 98 degrees. The next thing we're going to do is try to solve it for x. But as it stands now, x is attached to this sine function. So I want to isolate for the sine of x. So in order to, or the opposite of multiplying sine x by 23 is to divide both sides by 23. So if I divide my left-hand side by 23, I'm left with the sine of x. If I divide my right hand by 23, I have 13 times the sine of 98 degrees divided by 23. So keep in mind now, our answer is an angle measure. So I want to find x, not the sine of x. So in order to find x, I have to take the arc sine of both sides, or what we talked about earlier. So if I take the arc sine for the sine of x, okay, that's an identity which just gives me x. Whatever you do to one side, you do the same thing to the other. So I took the arc sine of the left-hand side. I must take the arc sine of the right-hand side. Right, so notice on the left-hand side, this produces an identity which is equal to x. I can put the right-hand side into my calculator. Oops. Okay, what happened to the problem? All right, so I am here. So if we put this into the calculator, right, I just want to make sure I'm still in degree mode. This is the arc sine of 13 times the sine of 98 degrees. Make sure you close off the argument for sine. And now I want to divide that by 23. And we get 34 degrees. They want us around to the nearest tenth. Right, so if I look at the tenth place, there's a 0. I look one number to the right, since that's less than 5, that will remain 0. So we have the missing angle x as 34 degrees. All right. Any questions about that example? Now this is question number 4, and it does not have a sketch to it, so we're going to put a sketch to it. All right, so remember that all these triangles are standard labeling. So it says solve for the remaining sides and angles, and it says if possible. If not, answer DNE, which means does not exist. Angle A is 11 degrees. So I'm going to just rough sketch out a triangle. I'm going to call this angle A, angle B, and angle C. I'm going to call this side A because it's opposite angle A. This is side B because it's opposite angle B. And this is side length C. So now I'm just going to put in all of our values. Angle A is 11 degrees. B is 23 degrees. A is 7. All right, so the first thing I believe we're going to do is find angle C, right? Because we know two angle measures. We can find the third angle measure by using that sum formula. So C is going to equal to 180 degrees minus 11 degrees plus 23 degrees. So if I put that into the calculator, we get 146 degrees. So notice that my triangle is not drawn to scale. Okay. And the reason why I'm kind of writing this down is because notice that angle C should be 146 degrees, which is an acute angle. Excuse me. Angle C is 146 degrees, which is an obtuse angle. And notice that the angle C for my drawing is an acute angle. So that's why I'm putting not drawn to scale. Oops. All right, so angle C should be 146 degrees. Okay, so that's 1, that's 11, 23, and 146. Okay. All right, we have side length A, which is 7. We have to find side lengths B and C. So next we're going to find B. Side length B. So we're going to set up a law of sines proportion. So remember, when you set up your proportion, there should only be one unknown. So looking at the things I do know, I know that side length A is 7, and I know angle A is 11. So I'm going to write this out as 7 divided by the sine of 11 degrees. And since I'm trying to find side length B, which is unknown, I'm going to write out the second half of my proportion as B divided by the sine of 23 degrees. Right, so there's only one unknown in my proportion. So now I can cross multiply. So I can cross multiply 7 times the sine of 23. So that's the 7 times the sine of 23 degrees. I can cross and multiply B times the sine of 11 degrees. To solve for B, I can divide both sides by the sine of 11. So 7 times the sine of 23 degrees divided by the sine of 11 degrees is equal to B. Right, so if I put this in my calculator, 7 times the sine of 23, and be mindful to close off the arguments for your trig functions. So notice I close off 23, because if not, you'll run into a problem. Divided by the sine of 11 degrees. Okay, close off my argument. And we get 14.3 is equal to B. And the last thing is to find C. Now, I cannot use the Pythagorean theorem because this is not a right triangle. I have to use another law of sines proportion. So we're going to find C. So here again, when I set up my proportion, there's only one thing I don't know, and I can solve for it. So I'm going to write out the first half of my proportion the same way we wrote out the first half of the proportion for side B, right? I know they gave us side A is 7, so I'm going to write out my left-hand side is 7 divided by the sine of 11 degrees. I'm going to set that equal to C, which is our unknown side length, but I know the angle opposite, so I'm going to divide C by the sine of 146 degrees. I'm going to cross multiply and divide. So 7 times the sine of 146 is 7 times the sine of 146. That's equal to C times the sine of 11 degrees. The opposite of multiplying C by the sine of 11 degrees is divide by the sine of 11 degrees. So 7 divided by the sine of 146 divided by the sine of 11 degrees is equal to C. And if we put it in the calculator, 7 times the sine of 146 divided by the sine of 11 is 20.5. So side length C is 20.5. All right, so any questions about the law of sines? Pretty simple to navigate through. Just want to make sure when you set up your proportions, you're kind of consistent with either the side lengths being in the same either numerator or denominator as well as the angle measures. All right, now before we continue, this is something that I want to point out. Now, the last time I taught this class, they changed up some of these problems. And before, they used to guide you. They'll say, like, find angle A, and then find side length B and side length C. And I'm just noticing that for the homework problems now, they're just listing out A, B, C, angle A, B, C, and side length A, B, C. So I haven't done all the problems just to make sure that everything works out like it's supposed to. But I want to bring this up. This is the data required for solving an oblique triangle. So remember, an oblique triangle is a triangle that does not contain a right angle. To solve these type triangles, you need to use the law of sines and the law of cosines. Here is the data required for using the law of sines and cosines. So it says that this is the first case. You have one side and two angles known as side angle angle. So I'm going to kind of sketch this out. Side angle angle. So what does that mean? These are just the dimensions I'm given. I'm given the dimensions or the measurement of a side length. So I'm just going to take any side. I'm going to draw a tick mark through it. So when I draw this little tick mark through it, that means that I should know this side length. You have a side length, you have an included angle, and then you have an angle measure. So this is my side, this is my included angle, and then this is the other angle. So this is how this works. I have the side length that I'm given. I have an angle measure that I'm given. And in between that side length and that angle measure, I'm given another angle measure. So this is the side angle set of measurements. And if you know what a side angle set of measurements, you can set up a law of sines. Now, this side angle can change based on how your triangle is rotated. Okay. The second case is angle side angle. So what that means is I'm given the measurement of two angles. I'm also given the measurement of the side included between those two angles. So this is what an angle side angle setup looks like. You're given an angle measure. You're given another angle measure. And between those two angle measures, you're given an included side angle, an included side measurement. So if you're given an angle side angle set of data, you can use the law of sines. So here's what I mean by that. If I go back to the problems we just taken a look at, for this first setup, for problem number 1, this would be a side angle. So this would be that case 1, side angle. So I'm given, well, I'm sorry. This would be side angle. Let me just erase this. Right, because I'm given an angle measurement, I'm given another angle measurement, and I'm given the side length between those two. So this is an angle side angle set of measurements. For this next problem, we are given a side length, which would be here. I'm given an angle measure, which is here. And in between that side and that angle measurement, I have another side. So this is a side angle. Okay. From this point going forward, whenever you're given a side angle side set of measurements, you have to be careful. And we'll see why in a second. Okay. And if we take a look at problem number 4, we were given angle A. We were given angle B. And we were given side length A. So this is an side angle setup. It's all based on what you're given. Now, the reason why I point this out is because if you're given a special set of dimensions, you got to be careful. All right, so this is the side angle setup, the angle side angle setup, which is case 1. Case 2 is called the ambiguous case. And the ambiguous just means you got more than one answer. For this ambiguous case, it's possible to have, and these are the possible solutions, and this is why it's ambiguous. You can have a no triangle solution. You can have a one triangle solution, or you could have a two triangle solution. So anytime you're dealing with the side angle, let me just draw this over here. So you have a side length, you have an angle measure, and in between that side length and angle measure, you're given another side set of measurements. So if you kind of flip this SSA around, you get the dirty word. So whenever you have a side angle set of measurements, and we're going to work a problem out next class, it's possible to have a no triangle solution, a one triangle solution, or a two triangle solution. So this is like the only case that you have to be careful of. All right, and that was case number 2. Case number 3 is a side angle side. So this is what a side angle side looks like. So this is case 3. All right. For side angle side, I'm given a side length measurement. I'm given another side length measurement. And between those two sides, I'm given an angle measurement. So that's my side angle side case. And then case number 4 is side. So if you're given 3 side lengths, you can use, we're going to talk about the law of cosines in the next class, but you can use the law of cosines to solve. All right, and then there is one more. Okay, number 6. All right, so I'm going to just copy this over. Okay, so this is number 6. Okay, this is still from the same section. All right. Okay, so let's take a look at this one. I think this will cover like all the scenarios. So this is number 6. So same sort of setup. They give us angles side set of measurements. And it says solve for the remaining sides and angles if possible. And I don't think they play any tricks up front. Okay. We're going to solve the triangle. All right. So I'm going to just sketch everything out. So this is a triangle with standard labeling, and this is not drawn to scale. This is ABC, side A, side B, side C. A is 93.9, side length A is 6.3, and side length C is 5.5. And I guess before I go any further, I'm going to go into the lecture notes, and this is in 10.2. So now this is what I was talking about earlier. They've changed up the homework problems, and I haven't answered all of them yet. But you can run into some problems where your answers can be different than the computer's answers. Not that you did anything necessarily wrong, but it could be the order in which you find these angle measures. So this is going to be important. So this again is coming from 10.2, and it says if you have case 1, which is a side angle or angle side angle, here is the suggested procedure for solving. The first thing it says is find the remaining angle using that sum formula, right, which we've done. And then the second step says find the remaining sides using the law of sines. Case number 2 is the side angle, right? That's the dirty word spelled backwards, the ambiguous case. And it says find an angle using the law of sines. Find the remaining angle using the sum formula. Find the remaining side using the law of sines. If I go to the next slide, case number 3, and this is where it starts to get a little bit tricky. Side angle side, it says if you're dealing with a side angle side, the first thing you should do is find the third side using the law of cosines. So we haven't talked about the law of cosines yet. But you should find the third side using law of sines. The second step says to find the smaller of the 2 remaining angles using the law of sines. The third step says find the remaining angle. Side says the first thing you have to do is find the largest angle using the law of cosines. Second says you can find either of the remaining angles using the law of sines, and then the third step is you can use the sum formula. As we work through the problems going forward, I'm going to use these suggested procedures. So I'm going to start using this suggested procedures with problem number 6. So the first thing you have to determine is what case are you dealing with? So as I look at this, I'm given a side length, an angle measure, and an included side. This is actually the side angle set of measurements. So if I go back to the side angle set of measurements, it says find the angle using the law of sines. Then we got to find the remaining angle using the sum formula, and then find the remaining side using the law of sines. So the first thing I'm going to do is find an angle using the law of sines. So what angle? So this is a side angle. The first step says to find the missing angle. Well, I actually have 2 missing angles. I don't know angle B and I don't know angle C. But I know side length A. We know angle A. I know side length C. I could find angle C by using the law of sines. Right? There's only one angle I can find based on the information I'm given, and it's angle C. So we're going to find C. So I'm going to set up my proportion. So A is equal to 6.3. divided by the sine of 93.9. And I'm going to set that equal to side length C, which I don't know, divided by, or excuse me, we do know side length C, which is 5.5. And we're going to divide by the sine of angle C, which is unknown. I'm going to cross multiply and divide. So 6.3 times the sine of C is 6.3 times the sine of C. That's equal to 5.5 times the sine of 93.9. The first thing I'm going to do is isolate for the sine of C. So I'm going to divide both sides by 6.3. So if we take the arc sine of both sides, C is going to equal to the arc sine of 5.5 times the sine of 93.9 divided by 6.3. And if we put that into our calculator, right, this is the arc sine, 5.5 times the sine of 93.9. Close off your argument for sine. Divided by 6.3, and we get 60.6 degrees.
You just leave that open for.
Okay. All right, so C is 60.6 degrees. So that was the first thing, right? On the suggested procedures, we found the angle using the law of sines. The next thing we want to do is find the other angle using the sum formula. So we're going to find the other angle, which is B. And we're going to use the sum formula. So B is going to equal to 180 degrees minus 93.9 degrees plus 60. So here you may want to use, remember, in order to avoid rounding error, you only want to round your last number. So that means if I put 60.6, I actually rounded at 60.6. I'm going to put in the 60.57437. So I'm just going to write it out as 60.5743 ... So I'm really going to just keep this value in my calculator, which is that 60.57. I'm going to add 93.9 to it. I get 154.47. And then I'm going to take 180 I'm going to subtract that from that 154.47, and I get 25.5 degrees. Notice you should only round your final answer. Okay, because if I use 60.6, I might get something a little bit different. All right. So angle B is 25.5. And the last thing to do is to find side B. So the third step is to find side B. So I'm going to do that here. So it says use a law of sine setup to find side B. So for the first part of my proportion, I always like to use the given information. Like they gave us 6.3 for side A, and they gave us 93.9 for angle A. So that's going to be the first part of my proportion. 6.3 divided by the sine of 93.9. And I want to set that equal to side length B, which we don't know. And we're going to divide that by the sine of 25.5256 ... which means I'm not going to use that rounded 25.5 value. I'm going to use this unrounded value for angle B. So what I'm going to do is I'm just going to take this 25.5256 and I'm going to store it. STO means store. And I'm going to store that for B. So the way I do that is I just hit STO, that's store. In order to find B, it really doesn't matter what number you use. I can hit alpha and apps, and that gives me B. And what it does is it stores that full value for B. All right. So now if I cross multiply, this is 6.3 times the sine of 25.5256 ... That's equal to B times the sine of 93.9. The opposite of multiplying B by the sine of 93.9 is to divide by the sine of 93.9. So 6.3 times the sine of 25.5256 ... divided by the sine of 93.9 is equal to B. So this is how I'm going to put this into the calculator. Remember that I already have this value stored for B. So I'm going to put this in as 6.3 times the sine of B. So in order to recall B, I'm just going to hit alpha and apps. Divided by the sine of 93.9. I close off my argument for sine. And we get 2.7. So B is equal to 2.7. And we have solved the triangle. All right, now there's one more fact, just one more thing to go over about a triangle facts. This is one of the facts, right? It says the sum of the interior angles of any triangle is 180. Here's another triangle fact. The largest angle is opposite the largest side length, and the smallest angle is opposite the smallest side. And I'll kind of tell you why this is important. Okay. So the largest angle is opposite the largest side, and this is for any triangle. It doesn't matter if it's a right triangle or oblique. The smallest angle is opposite the smallest side. Okay, the reason why it's kind of important to know these things is because when we take a look at these procedures, some of them says like find the smallest angle, like case 4, side, side, side. It says find the largest angle first. The largest angle would be opposite the largest side. So just to verify that, okay, if we go back to the problem we just worked, where is it? It's this one. My largest side length is 6.3, right? The largest angle in this triangle is 9.3, 93.9. My smallest side is 2.7, and the smallest angle in that triangle is 25.5. Right. So if you're trying to find like the largest angle, you would simply find the largest side, which is 6, in this case 6.3, opposite the largest side, you can find the largest angle. So when we meet next time, when it says like find the largest angle and find the smallest angle, we'll kind of know how to navigate through that. All right, any questions about the law of sines? All right, now the next time we meet, next week, we're going to take a look at the law of cosines. One quick thing about the law of cosines. Here are the law of cosine formulas. But these are not the formulas you're actually going to use. You have to modify them. For example, we find A, B, and C. We don't find A squared. We don't find B squared. We don't find C squared. So we got to like take the square root. We got to modify the formula. If you're using the law of cosines to solve for an angle, you basically take all of these formulas. You saw this first one for angle A, for angle B, and angle C. So when we meet again, I think I have them. Let me just check. Well, I guess we'll talk about that the next time. All right, any questions about anything up to this point? All right, well, no further questions. Class is dismissed, and see you all next week. Okay, that's fine. 3.3.
It's just the half angle identities.
Let's see. 3.3. Go back here. Okay, double angle. Which one was it? 7. Okay. This was one I was supposed to do.
Oh.
I had it. That's when the thing was messed up. Okay, but we can go through this one. So.
I just got to like a certain point where I had to.
Okay.
Simplify.
I got you. Print screen. Let me just copy this over real quick.
Yeah, that was really the only part.
I forgot to put the formulas on that too. Well, let's see, I think I got this already written down. Okay, here it is. All right, so for this problem, all right, so we're given this figure, and they want us to find the half angle for sine, cosine, and tangent. Now, just one thing about this problem, this is not in a rectangular coordinate system. So in those formulas, you have to determine the sign first. Since this is not in a rectangular coordinate system, the signs are going to be positive. Okay, so let me just copy these over real quick. Just so we will have them. Yeah, so here are the half angle formulas. And you notice like the formula for the half angle for sine, there's a positive and negative for sine and cosine. Since these angles are not in a unit circle, we don't have to determine the sign. Okay, so that's the first. I got you. And I believe they might have used the unit circle in those videos. I believe I watched a couple of them. All right, so let me just paste this in real quick.
I mean, the unit circle is helpful with the other ones,
but not so much with the problem like this. Okay, so the first thing we're going to do is I'm going to find the missing side. Now, since this is a right triangle, I can use Pythagorean theorem, right? So the hypotenuse squared is equal to a leg squared plus another leg. This is just another way to write that Pythagorean theorem. So the hypotenuse is equal to the square root of a leg squared plus another leg squared. So the hypotenuse is going to equal to the square root of 3 squared plus 4 squared, which is 9 plus 16, which is 25, which is 5. So that's going to be the hypotenuse. Now, let's find the half angle for sine. Oops. So now notice I got two angles. I have an alpha and a theta. We're asked to find the sine of theta over 2. So I'm going to treat theta as my reference angle, right? I'm going to label my sides according to this reference angle. So 5, that's my hypotenuse. The opposite is going to be 3. And then the adjacent is going to be 4, right? What is going on? And the adjacent has to be 4, right? I'm just going to write out the formula for the half angle for sine. So it says that the sine of theta over 2, and if I go back up here to my formulas, it should be the square root of 1 minus cosine theta over 2. Right? So up here I just changed the alphas to thetas because the theta is the variable in our problem.
You switched the alpha to theta?
Well, notice up here,
Oh,
they have alpha in the formula. That can be kind of confusing too. And notice that in my problem, I do have an alpha and I do have a theta, but they want the sine of theta over 2, not alpha over 2. So when I wrote out this formula, I just simply replaced that alpha with a theta. Okay. So in this formula, I got to substitute in the cosine of theta. But what's the cosine of theta? Well, if you go back to your triangle, and remember, this is right triangle stuff. So remember the chief Sakator. The cosine is the adjacent over the hypotenuse. So if I'm looking at this triangle right here, the cosine of theta, that's going to equal to the adjacent, which is 4, over the hypotenuse, which is 5, right? So that's the cosine of theta, 4/5. So I'm simply going to take this half angle for sine formula, and I'm going to substitute cosine for 4/5, and then simplify it. But are you okay with where we got the cosine of theta from? Okay. So now I'm just going to substitute in cosine for 4/5. So this is the square root of 1 minus 4/5 divided by 2. Right. So from this point, I want to multiply my numerator and my denominator by the least common denominator. So if I look, I only got 3 numbers, a 1, a 4/5, and a 2. The only thing that has a denominator is 4/5, which is 5. So 5 would be my least common denominator. So I'm going to multiply the numerator and the denominator by 5. So this is the trick to simplify this up a little bit, because I'm multiplying by 1. 5 over 5 is 1. Anytime you multiply something by 1, you're not changing the value, but you can change the way that the number is expressed. All right. So this is still in the square root. So I'm going to distribute 5 in my numerator. Oops. So 5 times 1 is 5. 5 times negative, 4/5 is going to give us what? -4, right? Because the 5s are going to cancel.
I think that's where I got stuck. I don't think I canceled that number.
I got you. And then 20 divided by 5 is 4, so that should reduce down to a whole number. And then if I distribute 5 in the bottom, 2 times 5 is 10.
Oh, so it was 20 over 5 turning into 4?
Well, now I distribute it. But 5 times 1, that's where this 5 comes in. And then when I multiply 5 times -4/5, that's where the 4 comes in. And then in the denominator, when I multiply 2 times 5, that's where 10 comes in. So then this gives us the square root of 1 over 10. Let me see, will it take this? Because at the view on the example, I think it's going to get like something different. See, it has square root of 10 over 10. I'm going to show you where that comes from. That comes from, I can rewrite if you have the nth root of a over b, then you can write this as the nth root of a over the nth root of b. This is like the quotient rule for radicals. So that means I can take the square root of 1 over 10. I can write that as the square root of 1 divided by the square root of 10, right? The square root of 1 is perfectly 1. The square root of 10 is not perfect, so I got to let it stay in the denominator. Then they rationalized the denominator. So what they did was they took the denominator, which is the square root of 10. I'm going to put an extra step in. And then they multiplied the top and the bottom by the square root of 10. So that's that same multiplying by 1 trick, because anything over itself is 1. So when I multiply this stuff together, I don't change the value, I can change the way it's written. So then, now since I'm multiplying fractions, I multiply the numerators, multiply the denominators. 1 times the square root of 10 is square root of 10. The square root of 10 times the square root of 10 is the square root of 100, which is 10. So that's where the square root of 10 over 10 comes in. I'm going to see if it'll take this answer. I think it will. But a lot of times when you look at the solutions, they like put them in a simplified form. And one of the reasons for it is because the people that are writing these solutions, they're working on their PhD programs, they're trying to impress people, so they try to make their answers complicated as possible.
For an example, that was on that question 7. Put it on that sin.
Yeah, probably they do.
Over 2 equals radical 26 over 26, and I didn't understand how they got that.
They do some weird stuff on that.
1 minus a fraction.
Right.
So I was stuck there for a while. It was like just that small step to get the final answer.
But is this okay?
Yeah, that's
okay.
A lot better.
So now we can do the other ones. So I'm gonna put in the square root of 1. I'm gonna just see if it should give me credit for it. We'll answer them all first, and then I'll put them in. All right, the second one says the cosine of alpha over 2. So, the cosine of theta over 2. So if I write the formula, the half angle for cosine, that is the square root of 1 plus cosine theta divided by 2. Yeah, that's the only difference, is just the sign, right? Yeah. Oops. So cosine is still 4/5, right? And nothing's going to change about that because we're using that same triangle. So this becomes the square root of 1 plus 4/5 over 2. And I'm going to multiply the numerator and the denominator by the least common denominator. So this is the step when you multiply the numerator and denominator by the least common denominator. This is the step that'll cut all fractions. So when this is still in the square root, so I'm going to bring that down. I distribute 5. 1 times 5 is 5. I distribute 5 times 4/5, which should give us 4. I distribute 5 in the bottom, and that's 10.
would be the final answer. You wouldn't do anything else.
I'm going to put this in, I'm going to see. But I can simplify this the same way. I can write this as the square root of 9 over the square root of 10. The square root of 9 is perfectly 3. So that's 3 divided by the square root of 10. And then if I rationalize the denominator, I should get 3 square root of 10 over 10.
Yeah, because some of them, when I get wrong, and it will eventually give me the answer.
And they look
it
like
would give
this.
Me like one of those.
Right. So if I look at this view example, yeah, that 3 square root of 10 over 10. And then for the last one, the tangent of theta over 2. Now here's one thing they didn't give you in these formulas. Like if I look here, they give us 2 formulas for the half angle for tangent. But this could also be, come on, I want this right. What is, oh, no wonder. I'm not on here. The half angle for tangent over 2, this could be written as the half angle of sine divided by the half angle for cosine. I don't know why they don't have that one on there, because the tangent is the sine over the cosine, right? So the tangent of alpha over 2 is going to be sine alpha over 2 divided by cosine alpha over 2.
So with the other two that are given, would those not work?
Yeah, they will work. The difference is, let me just look at the formula. You're kind of dealing with something that might be a little bit more complicated. We can work them out. We'll get the same answer. But here I have to put in the sine divided by 1 plus the cosine of alpha. And you got to simplify the denominator, simplify the numerator, and then divide. This formula, let me just go back to it. I can take the value we got for the half angle of theta over 2, and that was, it was the square root of 10 over 10. I'm going to write it out like this. I'm going to write it out as the square root of 1 over the square root of 10. Because that's the sine, alpha theta over 2. And I'm going to divide that by the half angle for cosine, which was 3 over the square root of 10. I'm just trying to pick something easy so that way I can just multiply this stuff and I not have to deal with like a square root too tough. So that's 3 over the square root of 10. And then the square root of 1 is 1, so I'm going to just write that as 1 over 10. So I'm going to take the simplest values, right? And I'm going to use that little formula I've been using. It says if A over B all over C over D, if that's your setup, then you can multiply the very top and the very bottom and multiply that by the bottom of the top and the top of the bottom. So that means I can multiply 1 times the square root of 10, and that gives me the square root of 10. I can multiply the square root of 10 times 3, which is 3 square root of 10. And then what's going to happen? and I get 1/3. So notice how you kind of navigated through it without doing a whole lot. So you should get 1/3. So that one should be, where is it? Yeah, that one should be 1/3. Now let me try to put these in. I think for the first one, where did I get? Okay, let's go back here. I'm going to try to put this in 1 over the square root of 10 just to see what it says. I believe it should give you the right, it should give us credit. Where is it? Let me just close these down. 1 divided by the square root of 10. Okay, this one was just 1/3, so. And then the half angle for cosine was, I'm going to put in 3 over the square root of 10 just to see what it does. 3 divided by the square root of 10, and